this video, I'll go over how to do the Unit 6 problems, which involves the solving of systems of equations by graphing. I will most likely do this in a few parts, just in case I make mistakes and I have to edit the videos that way. Also, I will be doing 1 or 2 questions from each section, and then I will let you do the rest. So, for the first 2 problems here that ask you to solve each system by graphing, it gives you 2 equations of lines, and what you are meant to do is graph the 2 lines and then find the point at which they intersect, which is how you solve a system. So for this first equation here, I'm going to graph it by first dotting the y-intercept at -1 and then graphing more coordinates by using the slope. So I'll go down 1 over 3 on the right and then up 1 over 3 on the left. And it'll look something like that. And then this other line I will graph by dotting the +4 intercept and then going down 2 over 1 on the right. And then you can see where the 2 lines intersect at the point here at 3, -2. So x equals 3 and y equals -2, and that is the solution to the system. For the second problem, I'll graph this equation by first dotting the -1 intercept and then going down 1 over 2 on the right, then up 1 over 2 on the left, like that. And then the second equation, I'll dot the -4 intercept and then I'll go up 1 over 4 on the right because it is a positive slope. And for this system, the lines intersect here at 4, the point 4, -3. So x equals 4 and y equals -3. So that's how you do those. For problems like number 3 and 4, where they don't give you the equation in slope-intercept form, you would just have to put them into slope-intercept form and solve for the y-part. For question 7, it asks you if the point, this point 3, -6, is a solution to the equations. For this type of problem, I would just plug in the 3 here for x and the -6 for y for each of the equations and just look for a true statement. But I'll just do an example. So for the first equation here, you have y equals 3x minus 15. And if I plug in the -6 for y and the 3 for x, that will give me -6 equals 3 times 3 minus 15. So -6 equals 9 minus 15. And -6 equals -6. So that one's true, and that means that the point 3, -6 lies on that line. So for the second equation, I'll do the exact same thing, which will give you 2 times 3 for x minus 3 times -6 for y equals -12. And then 6 minus -18 equals -12, which is the same as saying 6 plus 18 equals -12. And you can already see that this is not going to give you a -12, so this equation cannot be true. And that means that the point 3, -6 does not lie on this line, and therefore it is not a solution to the system. Otherwise, the point would have to lie on both the lines, and then you would know that the lines intersect at that point.